Hello everyone, welcome to Teacher Damien's math class. Usually, geometry is considered to be one of the easier courses in the subject of mathematics. However, there are still some topics that students collectively feel difficulty in. So today, we're going to cover such topics, namely sine and cosine laws. But before we get into sine and cosine laws, we're going to have to go through the basic trigonometry, Pythagorean theorem, and the trigonometric ratios. Then we'll get into law of sines and law of cosines, all right? Okay, so let's get into it. The basic trigonometry number 1, Pythagorean theorem. This regards the right angle triangle, which is the most fundamental shape of all geometry. When we have a triangle like this, we can name the vertices and call it triangle ABC. Okay, where the vertices are called like that, we can name the sides to be A, B, and C in that manner as well. You can see that the angles that we're going to be talking about, or vertices that we're going to be talking about, are named on the opposite side of the sides that we're going to be talking about. So A and A, B and B, and C and C are all on the opposite side of each other. That's because the angles that we're going to be considering will be corresponding to the length of the sides that we're going to be considering as well. So when the sides are named like this, A and B are the y and the x components of this right angle triangle, and they're going to be called the legs. C is going to be a little bit more special. The longest side in a right angle triangle is always going to be called the hypotenuse. Okay? Well, when the sides are given like this, the Pythagorean theorem shows us the relationship between all the sides as saying a squared plus b squared equals to c squared. Okay, let's move on, shall we? So another one that we're going to have to talk about in terms of basic trigonometry is the trigonometric ratios. There are sine, cosine, and tangent, but let's see how that works. Again, the trigonometric ratios comes from the most fundamental shape, which is a right angle triangle. This time, we're going to specify an angle that we're going to be regarding. Let's talk about this one. This angle right now, as you can see, has been denoted as theta. Theta is a Greek letter that we use to denote angles. Well, if this is the angle that we're going to be talking about, let's rename our sides. The side right beside it is going to be called the adjacent side. Well, the reason it's called the adjacent side is because, well, the word adjacent means right beside. The side on the opposite side of this angle, theta, is going to be called the opposite. Pretty obvious, right? But what about the longest side? We already talked about what that's going to be, and it's going to be called a hypotenuse. All right? So, having all the sides named, let's talk about the trigonometric ratios. Like I said, there are three things: sine, cosine, and tangent. Sine theta, so that means the trigonometric ratio, our angle theta right there for sine, is going to be given to us by the ratio of the side opposite over hypotenuse. What about cosine theta? Adjacent over hypotenuse. What about tangent theta? Opposite over adjacent. Pretty simple, but at the same time, it could be confusing to memorize at first. So in order to memorize this properly, you probably learned about this mnemonic. This mnemonic is SOHCAHTOA. SOHCAHTOA exists so that we can remember those letters, SOH, CAH, and TOA, in order to aid you in memorizing the trigonometric ratios. Since it has a mnemonic and everything, you can probably guess that this is very important. Okay? So let's make sure that we memorize it. So those are the two basic trigonometry that we have to talk about. But if you have noticed, we have a lot of restrictions. We're talking about triangles, but only right angle triangles. That's pretty restricted, right? So what if we don't have a right angle triangle? So this is when we get into something called the trigonometric laws. The first one is law of sines. If you learn the law of sines, it states that sine A over A equals to sine B over B and sine C over C. Yeah, you can use these in order to get the angle and size of a triangle that's not necessarily a right angle triangle. So it's very useful, but how does it work? Why is that a thing? So let's talk about this. As I have previously mentioned, triangle like this is a bit annoying because it's not a right angle triangle. So can we use trigonometry that we learned so far? Not really, we can't. But like I said, right angle triangles are the most fundamental shapes of all geometry. Which means if I draw a line like this, voila, I just made that triangle into two right angle triangles. So hypothetically, we can actually use our trigonometry from here, right? So let's name our sides and vertices, shall we? Vertices A, B, and C. And since we have drawn a line down the height of this triangle, let's call that bottom part D as well, okay? If that's how the vertices are named, we can name this side A and this side B, and the bottom side C, but we're not going to be using that for now, okay? So what can we do with this? Well, let's talk about our sine ratios, okay? Let's talk about our A. If we were to say sine A, opposite of our hypotenuse would look like this. Sine A equals to the side CD over sine small b. Okay, so let's rearrange that so we can have B sine A equals to CD, and we're going to leave it at there for now. Let's look at the other side of the triangle for angle B. So sine B equals to CD over A, because again, it's going to be opposite of our hypotenuse, and the new opposite for this triangle on the right side is going to be CD, and the hypotenuse is going to be A. Okay, let's rearrange it again so that it will equal to CD. A sine B equals to CD. Then, as you can probably notice, B sine A and A sine B both equal to CD, so we can put them together like this. And if we rearrange the given equation, we can get our sine A over A equals to sine B over B. Notice how that this could be flipped. Even if they were reciprocated, it would still be the same thing. A over sine A equals to B over sine B would work. Okay, as you can see, our law of sines was given to us. Oh, so if you're going to be using the sine laws, if we have a pair of angle and the side, we can get the other angles and the other sides as well. Hey, well, where did the sine C and C go? Well, in this example, we only got the sine A over A and sine B over B. However, if you flip around the triangle that's been given and do the same thing, we would have gotten the sine C over C as well, so we can have it just standing with us right there. So, but this also has a restriction. It's great that the triangle that we're talking about right now doesn't have to be a right angle triangle. However, it was given that we needed the pair, the angle and the side pair, in order to work with sine laws. But what if we weren't given a pair? What if we weren't given an angle and a side, but rather we got two sides and an angle which is not corresponding to the any of the two sides that's already given? Then are we just out of luck? We can't use anything? No, that's when we're going to be using something called the law of cosines. So the law of cosines, this is a bit more complex than law of sines. A squared equals to B squared plus C squared minus 2BC cosine A. Ew, that's a mouthful, isn't it? So I personally think it's going to be a little bit better to memorize if we rearrange this and say cosine A equals to B squared plus C squared minus A squared all over 2BC. But that's still long as well. If you think that's a bit more difficult, I'm sorry, we're still going to have to memorize this. Okay, so how does this come to be? Well, we're going to be regarding the same triangle, okay? And we're going to name everything the same as well, except we're going to be talking about the side C. But if you look at side C, it's already been divided into two parts. So let's call them a little bit differently. The one on the left side, we're going to be calling X. On the right side, we'll call C minus X. Then let's talk about what we can. Okay, first thing that we're going to be talking about is, well, cosine A. our cosine A is adjacent over hypotenuse, therefore x over b. Let's rearrange that so we can have x. b cosine A equals to x. Okay, let's leave that for now, okay? And we're going to move on to the other side, and we're going to say cosine b? No. This time, we're going to be talking about the right angle triangle on the right side, and we're gonna see that as a Pythagorean theorem. So we can say c minus x squared plus cd squared equals to a squared. Okay? Let's expand this out a little bit better. Okay? C minus x squared becomes not c squared minus x squared, but if you have to remember FOIL, c squared minus 2cx plus x squared plus cd squared equals to a squared. It gets a little bit long, but let's just keep this up for now, okay? But if you notice something over here, in this long equation, x squared plus cd squared is given to us. But is that the same thing from the right angle triangle from the left side? X squared plus cd squared should be b squared by Pythagorean theorem, right? So we're going to be substituting b squared for x squared plus cd squared and make it shorter like this. Okay, well, we still have the unknown x, except we already found x from our left triangle, right? So let's substitute in b cosine A. If we do that, this is what's given to us. C squared minus 2c times b cosine A plus b squared equals a squared. So this is a mouthful, like I said, but if you rearrange it and organize it a little bit better, that is our cosine law. A squared equals to b squared plus c squared minus 2bc cosine A. Now, like I said, if we were given 3 sides, we can find out one of the angles that's been missing. If we're given 2 sides and an angle that's not paired, then we can find out the side that's going to be paired with the angle using this. All right? There's another way of writing this down. We already mentioned it. Cosine A equals to b squared plus c squared minus a squared over 2bc. So this is how law of sines and law of cosines are proved. Knowing this properly, I hope is going to help you with your geometry. Okay? Right? Thank you for listening, and I'll talk to you in the next lesson. Bye.